Another day on section 4.4. Today we're going to go to what we call, first video is going to be about what we call the mean value theorem for integrals. Mean being average. So we're going to use this to find the average value of a function. Average value meaning y value. So how would we normally, if we came down and we looked at this function that I have here, this crazy swirly blue thing, if I wanted to find the average y value, what would you normally do? Well, normally you'd take the sum of all the y values, which would mean that I would divide it by the number of y's that I have. The sum of all your y. Well, if I was going to sum up all of those y values, well, there'd be this one, and 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 this one. On and on we go. And if I look back at what I really have in green, if I added up all of those y values, the fastest way to add all those y values would be to find the area under the curve, starting at A and going to B. So the sum of all of these y values would be the integral from A to B of f of x dx. That would add up all of these y values, starting and kind of totaling all of these things up. If I wanted to add up all of those y values, I'd do it by finding the area under the curve, and I'd use a definite integral. Well, then how many of those green lines would I have drawn? How many would I have? Well, I would have drawn an infinite number, but I would have drawn enough of them to get from A to B. So if I want to find this the average value of a function, I'm going to do 1 over the length of the interval I'm looking within times the integral from A to B f of x dx. This thing is called the mean value theorem for integrals. And it'll find us, is it related to the mean value theorem that we did when we were doing derivatives? Yes. And are we ready to make that connection today? No, we're not ready to make that connection today, but at some point I promise we will make that connection. All right, so find the average value of this f of x equals 3x squared minus 2x on the interval from 1 to 4. Then find where my function obtains its average value. So first off, if I want to find this average value, so I'm going to use this mean value theorem. So my average value, 1 over the length of my interval times the integral from 1 to 4 of 3x squared minus 2x dx. So if I want to do that, let's see, so now all we got to do is carry out the integral. So if I carry out this integral, so I have a 1/3, and let's see, antiderivative here, antiderivative of 3x squared would be x cubed. Antiderivative of 2x would be x squared. And we're going to evaluate that from starting at 1 and going up to 4. So I've got 1/3. And I've got, let's see, so if I plug in 4, I'm going to have 64 minus 16, or 48 ultimately, minus, if I plug in 1, I'm going to have 1 minus 1, or a 0. So what I really have is I really have 1/3 of 48 minus 0, or of, after all it's said and done, 48, and our average value would be 16. So there's the first part of this question. So if we called this part A, I'm now done with part A. Okay? Now, part B says, find where f of x obtains this average value. Well, if 16 is my average y value, in other words, the average height of the function on the interval between 1 and 4, well, then that 16 is the y value that I would need to solve for x. So I'm going to now take, when I go to do this part B, I'm going to take my f of x, and I'm going to set it equal to this 16. Well, what's f of x? F of x is 3x squared minus 2x, and I'm going to set that equal to my 16. So now I've got a quadratic equation, so I better get that thing equal to 0 as fast as possible. So how about 3x squared minus 2x minus 16 is equal to 0? See if we'll factor it. Hopefully we can avoid quadratic. 3x and x. Oh, let's see. I got to have a 2. So if we did, we could do 1 and 16, I think that's no good. 2 and 8, how about if we put a 2 here and we put an 8 here? That's an 8x in the middle. We'd want that to be negative. That's a positive 6x on the outside. If I had that now set equal to 0, I'd have two solutions. X would be equal to 8/3, or x would be equal to -2. Now, if I look back up at the interval that we were given, we were supposed to be doing this on the interval between 1 and 4, and since it's on the interval between 1 and 4, my function's going to obtain that average value at x equals 8/3. So that's mean value theorem for integrals.